Good day everyone, this is S111 and I'm here to talk about random variables and its two types, which are discrete and continuous. First, what is random variable? Random variable is a result of chance events. An example of that would be, for a month, an online seller keeps track of how many clothes they sell each day. It is a random variable as it is a number and the value is random, which means we don't know exactly how much clothes they sell each day. Here are the two types of random variables. Number 1, discrete. Discrete is countable. Two examples of that are the number of albums on a shelf, the number of tickets they sold for a concert. The keyword there is number. Next is continuous. If discrete is countable, continuous is measurable. Here are two examples, the length of a book and the height of an individual. The keywords there are length and height, because length and height are measurable. That is all. Thank you.
Greetings to you all. I am Carl Bandol, the reporter for normal distribution and its properties. First up, what is a normal distribution? The normal distribution is also known as Gaussian distribution. Is a symmetric probability distribution concentrated on the mean, signifying that the data around the mean occur more frequently than the data far from it. The normal distribution is the most common type of distribution assumed in technical stock market analysis and in other types of statistical analysis. A normal distribution is also called as a bell curve. It is called a bell curve because the curve in the graph of a normal distribution closely resembles a bell. This is what a graph of a normal distribution looks like. Now here are the properties of a normal distribution. First, a normal distribution is unimodal, meaning it only has a single highest slump or peak. It is always symmetrical at the mean. The mean is central value in a normal distribution. The mean, median, and mode is always equal to each other. It infinitely extends to the left or right. It is always continuous. A normal distribution's maximum height is located at the center. Values will continue to decrease if you will look to the left or to the right. Take note that the height never reaches zero, making it impossible to cross the x-axis. Area of the curve is always equal to 1. That is all. That is all for today. Thank you for listening.
Good day, everyone. I am John Aline S. England from the section E11G, and today I am here to tackle about areas under the normal curve. But first, let us review. What is a normal curve? Normal curve is a symmetrical bell-shaped curve representing the probability density function of a normal distribution. Let us see some characteristics of a normal curve. A normal curve is unimodal, means it has one point here at the top. And the normal curve is symmetric about its mean. Here is its mean, and it means symmetrical. It can be divided into two equal parts. This is 50% and this is another 50%. And normal curve can also be written like this. Variable x follows a normal distribution mean mu and a standard deviation sigma. Now, let's talk about the 68, 95, 97, 99.7 rule. Here we have an example given. The x variable represents the height. Its mean is 5.5 and its standard deviation is 0.5. Let us write that down here. What is the middle part again? That's right, the mean 5.5. Then we write the other 4. It's here. Because we have a standard deviation 0.5, we will add 0.5 to the mean here. So we can write this down. 5.5 plus 0.5 is equal to 6. And another 6 plus 0.5 is 6.5. That's we're going to add the standard deviation to the mean if we're going to the right. If we're going to the left, we will subtract 5.5 minus 0.5 is 5. Then we subtract another 4.5. The 6895 rule indicates that if 1 this area covered is 68%. 68% here. And if you move another, this covers 95. If we move another one, which is 7, and here 4. This mostly covers, which making it 99.7% true, because the area of a normal curve is equal to 1 or 100%. That.
For this topic, we will discuss application of normal distribution. Normal distribution is the foundation for statistical inference and will be an essential part of many of those topics in later chapters. In the meantime, this section will cover some of the types of questions that can be answered using the properties of normal distribution. The first example deals with more theoretical questions that will help you master basic understanding and computational skills, while the later problems will provide example with real data or at least a real context. Example. Suppose we literally want to compare apples to orange. Specifically, let's compare their weights. Imagine that we have an apple that weighs 110 grams and an orange that weighs 100 grams. If we compare the raw values, it's easy to see that the apple weighs more than orange. However, let's compare their standard scores. To do this, we need to know what the properties of the weight distribution for apples and orange. Assume that the weights of apple and orange follow a normal distribution with the following parameters values. Mean weights 100 for apples and 140 for orange. Standard deviation, apple 15, orange 25. Now we'll calculate the z-score. 110 minus 100 over 15 is equals to 0.667. And the orange, 100 minus 140 over 25 is equals to negative 1.6. The z-scores for the apple, 0.667, is positive, which means that our apples weighs more than the average apple. It's not an extreme value by any means, but is above average for apple. On the other hand, the orange has fairly negative z-score. It's pretty far below the mean weight for orange. I placed these z-values in the standard normal deviation below. Let's take the z-score for our apple and use it to determine its weight percentile. A percentile is the proportion of a population that falls below a specific value. Consequently, to determine the percentile, we need to find the area that corresponds to the range of z-score that are less than 0.667 In the portion of the table below, the closest z-score to ours is 0.65. The, ta- the table indicates that the area of the curve between negative 0.65 and positive 0.65 is 48.43%. However, that's not what we want to know. We want the area that is less than a z-score of 0.65. If the area for the interval negative 0.65 and the positive 0.65 is 48.43%, then the range from 0 to 0.65 must be half of that 48.43 over 2 and equals to 24.215%. Additionally, we know that the area for all scores less than 0 is sub 50% of the distribution. Therefore, the area for all scores up to 0.65 is equals to 50% plus 24.215% is equals to 74.215%. The value is slightly different because we use as the score of 0.65 from the table while the software uses the more precise value of 0.667. Thank you.